Okay, so today we're talking about multiplying a fraction and a whole number. And when we do a fraction and a whole number, we have to, sometimes there's different ways that you can show it. We need to show it a couple of different ways. We need to show our work or our thinking, our strategies a couple of different ways. So we're going to work on those options today. So the first thing we're going to do is put a problem here. 3/4 times 4. Okay, so the first thing you need to remember is that this whole number is going to be the number of boxes that you're going to create. Okay, so the whole number is the number of boxes. I really appreciate that you guys are looking at the screen. You're not writing anything else. You're just paying attention to what's going on the screen. So my number 4, I have the 4 whole boxes. And what are my boxes going to be divided into? Yes? 4. They're divided into 4 because 4 is my what?
Denominator.
The denominator on my part. Okay? Everyone say they're divided into 4
They're divided into 4
because that's my denominator.
because that's my denominator.
Because otherwise, how could you shade 3/4 if you don't have 4 in the box? So we have to make our whole numbers look like, or our box look like they're the fraction. All right, so the first way that I'm doing it, and this is a model. This is a model. One of the 5th grade texts states that you have to be able to create some sort of representation for your fraction, multiplying a fraction by a whole number, and this is the representation, okay? All right, so I'm going to shade 3/4. So this is 1, 2, 3. There's one model. And then 1, 2, 3. I'm going to shade that on each one of them. And then I have to let you know that there is a different way to do this model. But like, for example, this model might be Miss McQueen loves candy. She had 4 bags of candy and she ate 3/4 of each bag. This would be a model for that problem because there are 4 different models, 4 different items here, and so they're separate. You could do that because each of my bags of candy are different. So your model might look like this. Okay, this might be my Snickers, this is my Reese's, this is my Butterfinger, and this is Almond Joy. Okay. All right, now what you would do is just count what's shaded. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is 12. And the denominator is 4 because it stays the same. It's the same of what's shaded, of what's broken, the box is broken down, and the same as what you have here. Okay? All right, there's another way to show this very same model. 3/4 times 4. The same 4 boxes, but what I'm going to do is, this is going to be a continuous model. 1, 2, 3, and what that means is that instead of skipping the boxes, I'm going to make a continuous shade. So, and I'll show you what that looks like. I'm going to do 3/4 here. So that's 1, 2, 3. That's one group of 3/4. And then there's 1, 2, 3. There's my second group for 3/4. And then there's 1, 2, 3. There's my third group of 3/4. And then 1, 2, 3. There's my fourth group of 3/4. Okay? So the thing that I like about this model is that you can actually see your answer. Okay? You see your answer so much better this way. And this would be 3/4, that light blue, plus the red would be 3/4, plus that green would be 3/4, and then plus the other blue would be 3/4. When you're adding, your denominator stays the same. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, And we can see from that model that that equals what? 12 fourths, but what does it equal? 1/3? No, 3. 3 wholes. That's a whole thing shaded. That whole thing shaded. This whole thing shaded. Okay? And if you have this, it's 12 divided into groups of 4. Okay? Or 12 divided into 4 groups, and with 3 in each group. Okay? Now this is your mama's way. 3/4 times 4. This is mama's way. This is the way that your parents and I learned how to do this problem. 3/4 times 4. You'll put the 1 underneath as the denominator. This does not change the value of the 4. And then you multiply it straight across. 3 times 4 is 12. 4 times 1, 4. Same thing. 12/4 equals 3. Okay? All right, look at the problem that you have in front of you. The problem that you have in front of you. Oops. Wrong one. It says Jerry has 3 bags of candy. Each bag weighs a half a pound. How many pounds of candy does Jerry have? So I need you to draw a model for me of what you think this problem represents. Okay? Draw your model. It says how many bags?
3.
3. So if I were a 5th grader, I might do what? Draw
3 boxes.
3 boxes. Exactly. All right, and it says each of these boxes, or I'm sorry, each of the bags weighs 1/2 pound. So each of the bags weighs a half pound. I'm going to do this. Actually, I'm not going to do it that way. I'm going to pretend that this is 1 bag, this is 1 bag, and this is 1 bag. And this is going to be 1/2. This is going to be 1/2. And this is going to be 1/2. Jerry and his candy. There's 3 bags of candy. Now if you looked at this, it says how many pounds of candy does Jerry have now? So we know that multiplication is repeated what? Repeated addition. We know multiplication is what?
Repeated addition.
Repeated addition. So if we have 1/2 plus 1/2 plus 1/2. Isn't that this picture? 1 bag, 2 bags, 3 bags. That's the picture that we have here. Now, if using repeated addition, what's our denominator? 2. And our numerator? 3. So our answer is 3/2. Okay? 3/2. And then this is an improper fraction. You'd have to convert it. And so if you converted it, you could do 3 divided into groups of 2, or 3 divided into equal groups of 2. 2 goes into 3. 1 time. 1 times 2. 2. 3. Subtract 2. 1. Your remainder is 1. So your answer is 1. Your remainder is the new numerator, and your denominator is 2. It stays the same. So this would be your answer. Now the multiplication equation, the equation would be 1/2. And then how many bags do we have? 3. That's your multiplication equation. And we know that that equals 3/2, and 3/2 equals 1 and 1/2. Okay? So we've done the model here, we've done an addition expression, and we've done a multiplication equation. Now let's look at our number line. The number line goes to this problem. On the number line, we're going to show what we modeled. We're going to show what happened in the problem. So I can tell that each bag is 1/2 pound or a half pound. So I'm going to make my number line be divided in what? Half. What if my number line said 1/6 pound? What would I divide it into? 6. I would have 6 in here instead of just 2. Because this is 1 and that's 2. 1 and that's 2. So after you make your dividing lines, then you label. And we know that after the number, so this is before 1, so it's just a half, but this one is equivalent to 1 and 1/2. This is 2, and then 2 and 1/2. 3, 3 and 1/2. Does that make sense? Yes, no? Okay. All right, so put your pencil on 0. Put your pencil on 0. How many times are we going to jump? Total? 3, okay? But the first one we're going to go, one bag is going to be half a pound. So I'm jumping. This is my bag 1. And then I have to jump another half pound, so from 1/2 to 1 is another half. So this is bag 2. And then bag 3, I'm jumping from here. That's bag 3. What's my answer? It's 3/2 or 1 and 1/2. Okay? So you've looked at the word problem. You have created a model that could help you. You have an addition expression. We made it an equation by solving it. And we have a multiplication equation as well as a number line. Those are all ways that you could show your thinking, show your work when you're doing a multiplication, multiplying a fraction by a whole number.